Welcome back to DellyMaths Concepts. What we're looking at today is we want to determine the extrema of this function that we're looking at. And when we refer to the extrema, we're wondering if at certain time there is what we'll call a maximum, or it could be a minimum, or it could be a case where we have one of those settled points where we call an inflection. So we're going to check to see which one of these we're looking at. Is it this case, or is it this, or is it this one? Now, in order to actually do this, we're going to take a few steps, and the steps are as follows. So one of the first things that we're going to do is we're going to find the derivative. So we're going to find the derivative of the function. The second thing is to set the derivative to 0. Therefore, we'll be finding those critical numbers. And then after that, we're going to use our number line to find out if we're at max or minimum based on what we're going to be getting. And lastly, we're going to use those x values that we get, to substitute to find the y value. So we'll talk about that when the time comes. Now let's get to it. All right. It says f of x is equal to 4x to the third minus 9x squared minus 12x plus 3. So step one, we're going to find the derivative of this, or what we'll call f prime of x. So f prime of x is going to equal to, so we're going to be using the power rule. So we're going to take the power, in this case, the 3, and it's going to come down to multiply by the 4, and then we reduce that power by 1. For example, the 3 times the 4, and then x will now be raised to the second power. All right, and then the 2 will multiply here. So we have minus 2 times 9, and then x to the first power. And in this case, if you have this is actually 1. So basically 1 times 12. And then when you reduce this, it becomes a 0, so it's gone. So a constant is 0, so we're not going to have that. So let us rewrite this just to simplify what's going on here. So f prime of x is equal to 12x to the second minus 18x minus 12. All right, so this is our derivative function, which deals with our gradient, right? So that is step one. We found the derivative, so that is the first step. Now let's take a look at what we're going to do for the second step. So step one, we just found the derivative function. Step two, we're going to set the derivative to 0. And in this case, we're trying to find our critical numbers. So let us set this to 0 now. And why is this so? Because at our extremas, for example, if we're at a maximum, then the slope is an horizontal line, which means it's going to be 0. If we're at our minimum, the slope is going to be an horizontal line, which means we have 0. So in this case, that is why we're setting the derivative function to 0 to work this out. So let's get it. So we're going to set 12x squared minus 18x minus 12. We're going to let this equal to 0. And what I'm going to do is I'm going to divide throughout by 6 to make these actually smaller. So I'm going to divide everything by 6. And in this case, I'm actually reducing this to simpler numbers to work with. So we're looking at 2x squared minus 3x minus 2. And this is equal to 0. All right, so what we want to do here is we want to take this and we want to factorize it. 4 is 2 times -2, that's -4. So for -4, I'm going to use -4 and +1. All right, so basically here is it. -4x, +1, minus 2. When we say 1, we're talking about 1x, or we could just say x, right? So in this case, I'm going to factorize by grouping very quickly. So 2x is my common factor of that first pair. And then we'll have x minus 2 And as you can see, 1 will be here, and we'll have x minus 2, and this is equal to 0. So here are the factors: x minus 2 and 2x plus 1 equal to 0. So that's what we will be using right here, okay? So when it's factorized, this is what we have. So we have x minus 2 into 2x plus 1, and this is equal to 0. All right, so there it is. We have just factorized. Now we're gonna solve, all right? So as you know, it's either this is a 0, which means if I add 2 to both sides, then x is equal to positive 2, right? So this is one of my critical numbers. Or it's a case where 2x plus 1 is equal to 0, which means I'll subtract 1 from both sides. 2x is equal to -1. And then I'm going to actually divide both sides by 2, where in this case now, x is -1/2. So my two critical numbers are as follows. X is equal to 2 and x is equal to -1/2. What's next, right? So let's take a look. So the third thing that we're going to do now is we're going to go on our number line, and we're going to check to verify what's going on. So let us get into some details, right? So on our number line, okay? On our number line, what we really want to do is we want to check these numbers. So on the number line, we'll have, let us say, a 2 here, and we'll have a -1/2 to its left, right? So it's not about the scaling. We just want to have an idea. So what we're going to do is we're going to pick a number from each region. We're going to pick a number from that region. We're going to pick a number from in this region, and we're going to pick a number from this region. So we're going to pick 3 numbers that we're going to be using to try in our derivative function, all right, to test to see whether or not we're going to get a positive or a negative number. Now, why is this necessary? All right, let's pick the numbers, and then we're going to explain. So a number between -1/2 and 2 could be 0. So I'm going to be using when x is equal to 0 here as my reference. And then I could use any number greater than 2 and 3. I'm just going to use 3. And then less than a half, I could use x is equal to -1, all right, in that region. And so we're picking numbers from each region. We're going to try them in the derivative function. And this is why this is necessary. We know already that whenever we have a slope, a straight line, a slope, this is a positive slope. So this will be a positive number, right? And then if we're coming down like this, right, then this is a negative slope. And then if we have a critical number between this, then you would have seen that this would have been a max, right? Because we're seeing where we're going up, then we're coming down. And if I have this going like this, we're seeing where we are able to tell, right? So if I'm going down first and then I'm going up after, then this would have been a minimum, okay? And if I check, for example, let us say I'm checking right here, and I have a positive and then I get a positive again, then I realize that this is neither max or minimum. It would have been one of those settled points, or what we call an inflection. If we had a case like we have 2 negatives, like the point is here, and I check and I get a negative again, then we know that we also have an inflection. So we will looking to see if we'll be changing signs or we're going to keep the sign. So if the sign change, then we could tell if it's max or minimum. But if the sign remain, like we have a negative and then a negative, or a positive then a positive, we're at an inflection. All right, so let us take a quick look at what we're about now. Let us get into the math. All right. So we're gonna take the derivative function, and here it is. Here's my derivative function. It is 12x squared minus 18x minus 12. So what I'm gonna do is I'm gonna be utilizing these numbers right here. So basically, I'm finding f prime of -1. I want to know what this is equal to, right? So I'm going to substitute -1. So wherever my x is, I'm going to remove it, and I'm going to put -1. So I'm going to substitute -1. We're putting in -1, as you could see. So -1 square will still be positive. So +1 times 12 is 12. And this is going to be +18, and then we take away 12. If you should put all of this on our calculator, we're going to get 30 minus 12, and this is 18. As you could see, the negative and the positive 12 would have gone. We're left with 18, which is a positive number. So what this is telling me is that in this section, we have a positive, right? Positive, which is okay, right? So we understand that we're going up like that. That's what that means right there. And we're going to put 0 in it now. We're going to try f of 0. So let us try f of 0 right here. Prime of 0 is going to equal to 12, 0 square minus 18 times 0 minus 12. And in this case, we're looking at 0 minus 0 minus 12. This is going to give us a minus. So this is a negative right now. So that means we're going down here now. So here is telling us that we have a negative. So what it means then at -1/2, right? Because we try points to the left and the right of this critical number here. And so this would have been where -1/2 is right here. -1/2 would have been here. So we actually had a positive slope and then a negative slope. So at -1/2, we're seeing where we're at a max right now. We're at a max right there, right? And that's what we're talking about. Let us now check. We're going to have to check to see what's going on when we go beyond 2. All right, so we're going to try f prime of 3. So it's going to be 12. This is our derivative function. 3, we're going to square minus 18 times 3 minus 12. All right, so this is going to be 12 times 9 minus 54 minus 12. Right? So 12 times 9, 108. So this is 108. And 108 minus 54, then minus 12. We're getting a positive 42 here. So we're going up like this again, right? Positive. Now, remember that this is where 2 is, okay? So we just checked to the left and the right of the two critical numbers. And when we did, we are getting a minimum here, as you could see. So it's helping us to understand a few things. What it is saying to us is that when x is equal to -1/2, we're at a max. We're at a max right here. And when x is equal to +2, we're at a minimum right there. So we're almost through with all that we're doing. So now we're going to have to go back and find the point itself, okay? So we know where our max and our minimum is. So now the last thing that we're going to do is that we're going to find that y coordinate, right? So let's deal with that. Now remember that when you're finding this y coordinate, you have to go back in the original function. So to get the y coordinate, you got to go back in that original function from the beginning, okay? Original function from the beginning. So let us not mix that up with the derivative. So I took that off. So we can't make that error. We are going for the original function. So the original function that we had, it says f of x is equal to 4x to the third minus 9 x squared minus 12x plus 3. And we're going to take that function and we're going to insert our x values at max and minimum. So the first one that we're going to do is we're going to see what it is at our maximum, which is going to be, we want to find f of negative a half right here. So it's going to be 4, and then we're going to have negative a half raised to the third minus 9, negative a half squared minus 12 times negative a half plus 3. So as you can see, we're just substituting there. We could just work this out quickly. So this is going to be 4 times, all right, negative 1/8, as you could see, negative 1/8 minus 9 times positive, minus 9 times, and it's going to be a positive, no, positive 1/4, because remember, when you square negative, it's a positive, all right? And then minus, so 2 minus is going to be a plus, and negative 12, negative a half, so it's going to be positive 12 times a half right there, and then we're adding 3. All right, just to take all the steps. As you could see, I could cancel 4 into itself 1, 4 into this 2. So this part at the front is negative a half that I have right there. And then for this, I have minus 9/4 coming out of that. But for this part, I'm getting a 6 when I cancel. So this is a plus a 6, a plus 3. And we could now break it down easily. So let's do this quickly. I'm going to represent the half using 4. So I'm going to represent this as negative 2/4 minus 9/4. And I'm going to add 9 when I'm done, right? So what we're looking at is negative 11/4 plus 9, which is going to be 36/4, as you could see. So we're looking at 25/4. Let me write my file a little bit better. All right. So we're looking at 25/4 right here, right there. All right. So that's 25/4 for my y value here. At my maximum, I have this point here, right here. There it is. So my maximum, so my y is 25/4. So the coordinate is right here. That's at my max, right? Now we want to see what goes on at our minimum, okay? So at the minimum, we're still going to evaluating the f of 2. That's what we're going to do. So it's going to be 4x to the third. So it's going to be 2 raised to the third minus 9 times 2 squared minus 12 times 2 plus 3. What are we looking at? 2 to the third is 8 times 4, that's 32. 2 to the second is 4, 4 times 9, which is negative 9, this is negative 36, minus 12 times 2, this is 24, and we're adding 3. So our 32 minus 36, that's going to give us a minus 4, minus 24, that's minus 28. And then when we add 3, we're getting negative 25. So now let's put it together finally. So these are our extremes. So at maximum, right? At maximum, we have the point negative half, 25/4. And at minimum, we do have positive 2 and negative 25.